Hello, good evening, everyone. I hope everyone is well. I want to extend a quick apology for the fact that we missed Mondays and the resulting class had to be recorded now. Okay, so we're gonna briefly go through set theory. That right? Okay, so we started off by understanding that sets is really just naming or declaring a group of objects or things. Whether they have common characteristics, they form a set, right? And in using the set language, we must understand that it is has to be clearly defined. All right. When you're describing a set, for me to understand the members, I need to know the definition and the description of your set. Some examples of sets would be sets of vowels in the English alphabet, sets of planets in our solar system. Those are clearly defined and descriptive. Okay. Now, when we are naming sets, the format is always going to be starting with a capital letter. All right, these notes are for you, but I want you to write them in your book. All right, if we are speaking of the set of students in a school who study Spanish, then we may choose to name the set of S, where Spanish means S. But remember, we said that the language of mathematics is really coming from English. So when we see S is equal to curly bracket, this is saying the set of S is the set of students at our school who study Spanish. So go again. A is the set of multiples of 10. B is the set of words that begin with the letter P. Perfect. Now, once we understand the naming of our set, then we moved into okay, what are the actual definitive members or elements, right? Those are the things that are actually contained in those sets, right? So, quickly, let's look at an example of the letters of an alphabet. We can say the set P is equal to ABC. The actual members is denoted by a symbol E, right? This symbol is used to say it is an element or it belongs to. So if I want to say A belongs to the set of vowels, I can therefore say A using the symbol between E, P will tell me A is an element of the set P. That means it's a vowel. That means it's an element of that set P, which is all vowels. Hope you guys understand that. So the opposite is very clear. If something is a set of, to say not a set, you would simply put slash between the E or not a member. Okay? Now, once we did that, we then moved on to some examples and we said, for example, I want to say U is a member of A, which is vowels. I therefore say U, E, A. One more example. P is not a member of A. I say P is with a slash in between A. Right? Okay, good. Then we moved into the number of elements in a set. How do I declare the amount of members that I have? And I quickly went through this exercise on our first meeting on Monday. We said the symbol N means number of, right? And then when I want to find the elements in a set, I need to write the set name. If it's that's A, B, C, or any other letter, you put the number of elements in that set is equal to the value. That's how you express the number of in the sets. And we call that the cardinality. Hope you guys remember that, the cardinality. Okay, now when we finished this example, I gave some examples to follow. If I say I have a set B, which is equal to cherries, plums, mangoes, and oranges, the number of elements in B is equal to 4, right? If I have an element, sorry, if I have a set D, is the set of multiples of 10 between 39 and 99, right? It's going to be 40, 50, 60, 70, 80, 90. the number of elements in D would be, let's count them, 1, 2, 3, 4, 5, 6. Okay, and then when we finished that, we talked about the fact that to express that I had nothing in a set, you use two symbols, either the curly braces or as O with a slash between. Okay, I know you guys know this, so I will just quickly go through empty sets. Days of the week which start with the letter L. How would I express this? You simply put the symbol two curly brace or O with a slash after it. All right? So these are four examples of empty sets. And not only do we have empty sets, we actually have finite sets, which is where the set is actually completed. It begins and it ends. All right, let's quickly read this paragraph. If a set is countable, then it is finite. If a set is infinite, then it is not countable. It is impossible to, right? Hence, it is not possible to state the cardinality. Right? The cardinality, as you said, is the number of elements in that set. Okay, let's do a quick example for finite sets. If I say the set of prime numbers between 1 and 10 is finite, name this set and then tell me the number of elements in this set. You're going to first is write in English statements. A is the set of prime numbers from 1 to 10, and then you're going to declare that set for me using mathematical statements. Then you're going to say A is the set of 2, 3, 5, 7. And the final step, to list the members of the set or the cardinality, you put N bracket A is equal to 4. Here's another example for us to go through, but quickly, we're going to move into infinite sets. To talk about infinite sets, as we said, is not countable. How many persons are going to get 100 in the exam? It's not countable. It's infinite. All right? So we're going to look at a quick example. The set of multiples of 5 is an infinite because it can go on for forever. 1,000,005, 1,000,000,010, 1,000,000,015. Right? It will never finish. So we represent this by putting an ellipsis at the end of the number you want to stop at. So let's say we're counting of increments 5, 10, 15, 20. After I say 20, I can put 3 dots to show it continues for forever. You guys know this, all right? But the next thing, what if I want to note this? Not only know this, but I want to note this. I would use set builder notation. Let's break it apart. It is very convenient to understand how to describe the elements, right? Sometimes it's very hard to list it, guys. What if you're listing 50 different numbers? Sometimes you can't list every single digit. So you use set builder notation. All right? It can help you to list real elements in short order. So if you wanted to list all the values of x that is greater than 5, right? That's an infinite value. Set builder notation actually can represent this, right? We can say the set of x, remember the curly brace means the set of x, the colon mean such that x is greater than 5, comma, x is an element of real numbers. Okay? That's how we express this statement. Let's do another one. The set of all values of x such that x is less than 5 and greater than 1, and x is a member of the set of natural numbers. Okay, my bad. It was to be integers for z, right? But for natural numbers, you're going to put n, right? And I'm going to give you a short table that shows you all of the different symbols, all right? But this is just an example of how you represent the set builder notation, okay? So if you have a range of less than 5 and greater than 1, then x is less than 5, but x is also greater than 1. So 1 is less than x is the same thing as x is greater than 1. And then now x is less than 5 is the same thing as 5 is less than x. All right? Okay. Then we summarized everything by knowing that this is very similar to inequations, where you write things on a solution set. Hence the term set builder notation. It's very similar. It rhymes. Okay. So to summarize, You may use words. For example, the set of multiples of 2. You may list the elements, for example, 2, 4, 6, 8, and then you could express them using set builder notation. For example, the set of x such that x is a multiple of 2. There are 3 ways to describe a set. You guys should take this off, right? I'm going to make sure you take it off. We're going to pause there. You can quickly catch up next class when I record this.